We are up to 2-3 day 2, and it's just piggybacking 2-3 day 1, obviously. We're going to add a little bit to your factoring skills. Today we're going to actually solve equations that require factoring. So we'll start with the basics. If A times B is 0, then you should be able to conclude that A has to equal 0 or B has to equal 0, because you multiply two things together and get 0. One of them or both of them need to be 0. How do we apply this to a math problem? Right here. Here's my A, here's my B, equals 0. So how do I figure out what value for x will cause this to be 0? Just look at it. What minus 2 is 0? 2. What plus 3 is 0? Negative 3. So there would be my answers. Now, are they going to be that easy? No. As you can see, you're going to have to factor them first, because this needs to look like this, which is actually this. So we look at this, we call this a Gauda one. 2 factors of 8 that add up to 6 are 4 and 2. So we can just rewrite that trinomial in a factored form. X plus 4, x plus 2. Now we solve it. What plus 4 is 0? Negative 4. What plus 2 is 0? Negative 2. Pretty basic, I hope. Now we got a nada one. So we got to take our time and factor it. So it's negative 18. 2 factors of negative 18 that add up to negative 3. I'm going to just jump right after it. Negative 6 and 3. I'm going to rewrite it. 2x squared minus 6x plus 3x minus 9. Notice I wrote the positive 1 second because I want that plus there. It's not required, but it just helps. So I'm going to insert my parentheses, factor out as much as I can. I get x minus 3. Take a 3 out, x minus 3. Now remember, this equals 0. I just kind of forgot it for a little while. Here's my match. So I get x minus 3 times 2x plus 3 equals 0. Now this is the first time we've had something like this. We'll talk about it in a minute. This one you can just look at it. Well, what minus 3 is 0? Well, that would be 3. If you're confused on these, literally take it and set it equal to 0 and solve it. So I'm going to subtract 3, 2x is negative 3, divide by 2, I get x is negative 3 halves. Now if you're looking for a little trick, and I mean a little trick, all you got to do is take the opposite of that. So what's the opposite of positive 3? Negative 3, and then divide by that coefficient. Essentially you're doing it in your head. You're doing all of this in your head. So there's my 2 answers for this problem. Now example 3 is a little different spin because we have a difference of 2 squares. So if you remember, we haven't dealt with a lot of them, but just take the square root of that, goes first, take the square root of that, goes second. One of them needs to be positive, one of them needs to be negative. So once you've done a bunch of these differences of 2 squares, it's not too bad. So what value for this will cause this to be 0? Negative 7. What value for this will cause that to be 0? Positive 7. Remember, if you have a sum of 2 squares, you can try for the rest of your life to try to factor it, and it is not going to work. We'll talk about that later on. What do you do with this situation? But just know you can't factor a sum of 2 squares. That's about half. All right, now we're going to take what we learned and actually apply it to a real parabola. They're going to ask us questions. Identify the intervals, we'll talk about that in a minute, where the quadratic, that's just a fancy name for a parabola, function. Now how do we know it's a parabola? Just look at this, y equals x squared. You guys have had enough of those. And where it's positive, which means it's above the x-axis, or negative, that just means it's below the x-axis. Keep all that in mind. We look at this, and you got to really understand what I'm about to say. What we've been doing is we've been solving problems like this. And I'm going to come back to that in a minute. The first thing you're going to do is find what's called your zeros. Now I'm going to talk about that in a minute, your zeros come from here because you're going to solve this. As you notice, this is a gotta one. So we're going to go x and x, two factors of 3 that add up to -2. I think this is supposed to be a -3, so we'll go like that. -3 and +1. So my two zeros are 3 from here and -1 from here. Now what's our zeros? Those are our x-intercepts. So I find this, 1, 2, 3, put a dot there. -1, right there. Now I want you guys to notice something. The original problem was a y. I set y, watch this, equal to 0. Why is that true? Because that point is actually -1, 0. Notice y is 0. This point right here is 3, 0. Again, my zeros is another word for your x-intercepts. And if it's on my x-axis, that means my y needs to be set equal to 0. And that's how you get kick-started. So there they are. But the question isn't asking, draw the parabola. It's saying, where is it? Positive, above the x-axis, negative, below the x-axis. Well, because our leading coefficient is positive, we know it's a happy face. This is not asking you to find the vertex, so don't get too freaked out about that. This is just saying, hey, generally speaking, our parabola is going to look like that. Now, is this perfect? No. But I do know it's a happy face because my leading coefficient, my a, is a +1. That's a happy face. You see the happy face? So, where are things positive? Well, for a moment, I'm going to get rid of this. And that is positive from -infinity all the way to -1. It gets a little tricky. This is parentheses, this is parentheses. Now, a lot of students want to put a bracket there because that's filled in. But remember, that is on the x-axis. We want stuff above. So that's why that has to be a parentheses. But it's also positive here. From 3, but not including 3, because 3 is on the x-axis. We only want stuff above it. So I've got to use parentheses and then to infinity. Now I'm going to get a different color out. This is the stuff below the x-axis, the red. So where is it negative? From -1 to 3. How do I say that? -1 to 3. Again, why don't I have brackets? Because those dots are not below the x-axis, they're strictly on it. That's why I have to use parentheses, so you have to be careful with that. Same problem, well, same question, different problem. So the first thing we're going to do is we're going to find our x-intercepts, which is another way of saying let y be 0, because we're going to find our zeros. All right. So the first thing we're going to do right here, sorry, I made this kind of messy, is 0 equals negative. Now, what I'm going to do is kind of fancy. You see that right there? I'm going to take a -1 out, and that will leave me with x squared minus 6x minus 16. And then I look at this and I say, okay, now I can factor it. So I go x minus 8, x plus 2. Yes, there's a -1 there, and that's very significant. So how do you know to take that -1 out? Practice. Remember, a GOTA1 trinomial is the easiest trinomial to factor, so you take a -1 out of everything, just to make life a little easier. So where are my zeros? Well, x is 8 and -2. So I'm going to put the -2 right here. 1, 2, 3, 4, 5, 6, 7, 8, way over here. Now watch, this is a -1. I could have seen it from here, which means it's a sad face. And that means it's going to go like this and like that. Perfect? No. Where's my positive? That's anything above the x-axis. So this is -2, 0. This is 8, 0. So I can go from -2 all the way to 8. That's the stuff above the x-axis. That's my answer for the positive. Now I'm going to get rid of that. Now we're going to talk about the negative. there's two chunks. There's this chunk, so that's negative infinity all the way up to negative 2, parentheses, and this chunk. Get rid of that, and that's from 8 all the way to positive infinity. And there you go. There's a little slightly different one. It's a sad face. A little different than the first one. One more sample problem and we'll be done. Last problem, a little different, because we've got a not a 1. So you're like, oh, take a 4 out of everything, like you took the negative 1 out. Nope, that's going to mess everything up. There's just not an easy way to factor out a 4. So we're just going to try to factor it. So that's negative 20. Two factors of negative 20 that make negative 8 are negative 10 and 2. So I'm going to rewrite it. 4x squared minus 10x plus 2x minus 5. Slap your parentheses in there. Take the 2x out. I'd be left with 2x minus 5. Notice I got that, but I had to take something out. So I take a 1 out. And then I'm done factoring. Whoops, that's supposed to be a minus 5. And then 2x plus 1. Now don't forget, you're trying to find the zeros. So you set y equal to 0. And now we're going to get a little bit of an idea what this looks like. Remember the trick? Take the opposite of this, which is 5. Divide by that, which is 2, which is 2.5. So 1, 2, 3, that's right there. So that's 2.50. Take the opposite of this, negative 1. Divide by that, 2. If you don't like that trick, just set it equal to 0 and manually solve it. Negative a half is right there. So that point is negative 1/2, 0. Notice this is a positive. There's also a positive 1 right here. So we know it's a happy face parabola. So it's going to look like this-ish. Where's the positive? It's this chunk right here. So that'd be negative infinity all the way up to negative 1/2, parentheses. And this chunk from 2.5 all the way forever that way. It's above the x-axis. Where's the negative? In between these two points. So there's it. There's the portion of the graph below the x-axis that goes from negative 1/2 all the way to 2.5. And there's your pre-lesson / maybe your sample problem. I don't think there was a pre-lesson. So good luck with that homework.